Good afternoon all. Now let us see the case study of signals and systems in speech signal recognition. See, signals and systems plays a vital role in speech recognition systems. See, speech signal is nothing but your time varying acoustic signals that produces speech from human voice, right? That is nothing but speech recognition, right? It is a one or more independent variable which contains some information is called as your signals. See, signals and systems plays a vital role in speech recognition systems, so including voice systems, smart devices, etc. Right? In this case study, we are going to see about these speech recognition systems, how we are applying signals in terms of signal acquisition, reprocessing, filtering, and in real-world applications. Let us discuss briefly.
The main objective of this case study is going to see about signals and systems in a speech recognition system. Like integrating the signal, how the signal has been created and how it's implemented. And we are going to the system, how the system uses the signals to convey its information and correct the most important thing. And by integrating both these in the speech recognition technologies, we create most easier one, like it is used in many applications like wearables and voice assistants. And also here we are going to highlight about the advantages and applications of speech signal recognition.
Steady background in speech signal recognition. Speech signal recognition converts the speech signals into the digital text by using several fundamental concepts. In that, we can see signals in speech recognition. Speech signal is an analog waveform that can be produced by vibrating the human vocal cord, and that varies in amplitude and frequency over the time. And that signals carries the linguistics like words and the paralinguistics in emotions and pictures, etc. And we can see in systems in speech recognition. Systems recognition, the speech signal that's as a classifier that transforms the captured speech signal into textual or the common outputs, and using the multiple several processing units.
See, speech signal recognition can be represented in terms of analog form or digital form. See, analog form is nothing but they are continuous in amplitude and continuous in time. See, discrete time means how they are representing in terms of only discrete in time. See, process of conversion of analog to digital is nothing but your sampling process. See, sampling process is nothing but conversion from your analog domain to frequency domain. How these speech signals are analyzed, how they are measured in terms of sampling frequency with the help of Fourier transform by converting time domain into frequency domain. See, with this all these structure, the speech signals are analyzed for pre-processing unit, filtering unit, and then how they are applied in terms of real-time applications.
The working principle of a speech signal recognition system. The working principle of a speech signal recognition system is used to convert a spoken words into a text words or the commands. We following a few steps, which is like a signal recognition, pre-processing and a filter, pattern recognition, output and classification, and feature extraction. The first is a signal recognition. A signal recognition is used to convert a voice into a clearer and louder. It makes our voice can be recorded by using a microphone. Our microphone can convert a text into microphone can convert a voice into a signal which make a clearer and louder. At last, quiet place can hear the noise hear the voice very well. And next is a pre-processing and the filter. In the pre-processing, we used in our microphone we have an extra noise, so we usage of filter, we remove the extra noise, and then it may the sound will be adjusted at the right level. right level, and then it will make a clearer and more louder. And then we go to next step. The next step is the feature extraction. The feature extraction is the computer picks up some notes about our voice. It's like a pitch, sound recorder, and also a pattern, and then it will change us into a clearer and more louder by usage of the computer. And the next is a pattern recognition. The pattern recognition is used to computer can collect a voice, and it can be changes into a data, and then data can be processed very well, and then it will give a proper word and information.
Moving speech recognition. When we speak, our voice is an analog signal, and microphone captures this and is converted into a digital signal. These signals are passing through the three stages like pre-processing, where the noise is removed, and future extracted. Then the signal is compared with the stored pattern in recognition system. Then finally give you a text output. System modeling and analysis. In system modeling and analysis, each stage is referred as the system block, like input, process, and output. And engineering student, engineer studies how the systems are affect the signals, like its frequency response and accuracy.
Now we can going to see about the signal flow in speech recognition systems. First is speech. That speech signal is converted to microphone that can be applied for filtering process. See, filtering process can be applied with the help of IAR filter design or FIR filter design. We can remove the unwanted noise by using the filtering process, and also we can feature the extracted speech recognition systems that can be applied for pattern matching. We can get the recognition output. See, pre-processing means to remove the background noise. See, with the help of these filters, you can remove the background noise for speech recognition system. See, with the help of linear time invariant systems also, we can going to recognize from your time domain into frequency domain. How these speech signals are analyzed and then filtered, and how that can be applied in terms of your real-time applications.
So I'm now going to talk about application. So speech signal recognition plays a major role in many fields. In voice system, for example, Alexa, Siri, Google Assistant. So in this, it helps the device to understand and also to respond what we say. And also in healthcare, it helps the patients who can't use the physical devices. So by using this, they can control the system just by speaking. And also it is used in security system. So in this, it uses a voice-based authentication. So it identifies the person just by through their voice. And also it is used in automobiles. So in that, it helps the drivers to make calls, to pick calls without taking their when they are driving. And also it is used in educational purpose. So in this, it helps the learners to improve their communication skill, fluency skill, and pronunciation. So these are the applications.
In challenges, there is a background noise and no fast processing in real-time speech, and in complexity for multiple language implemented, and there is a large data sets are needed for training. In advantages, there is a helping for physically challenged users and reduced manual typing work, and in human and computer interaction is easier and faster. It is the advantages.
Now let us conclude. So speech recognition plays a vital role in signal acquisition systems, right? It is used in like voice assistance, healthcare, and in automotive systems, security system purpose in terms of speech recognition, and also in education. See, speech recognition means first we are converting from your analog to your digital signals, and with the help of additional features like signal acquisition, pre-processing, filtering process, these are all the process can be made. How this speech could be extracted, right? And for how can be implemented in real world applications. Finally, the evolution of signal processing techniques combined with artificial intelligence to continue the speech recognition system more accurate, natural, and human-like in the future. Thank you all.